now take a look at one more example. So in here, so circuit was given, and there is two independent source, one voltage source and the other one is current source, and now those are all connected in parallel. Now we need to find out the Thevenin equivalent circuits. Alright, so now here is same thing. So we can create, we need to find out the VOC, which means that the Thevenin voltage, and also we need to find out current SC, or we can use RT, which means the Thevenin resistance. Okay, we can calculate the Thevenin voltage. So we can use one of method, node voltage analysis or mesh current method. So I want to use node voltage analysis. So here, this is a node 1, node 2, and node 3. So now here, that one is 20 volts, voltage 1, V1 is 20 volts, and the other end, this is the reference, so which means that ground 0 volts, and this node is 0 volts. Those are all the same, they connected into the 0. So now this is V1, we can say that's V1 node voltage and V2 node voltage, and then we need to specify current. So current coming out and in these directions, so we can say that I1, and then they going down, which means I2, and this one's coming in these directions, so this is the I3. Okay, so now here, node voltage analysis, VT. So we can apply KCL equation first. So KCL equations, and not, we say that, oh, this is node 1 and node 2. So in node 1s and KCL equations, which means that current coming in, I1 coming in, and plus I3 also coming in, and coming out I2. I3 was given 2 amp, so they coming in 2 amp, so 2 equal I2. Now next, so we need to figure out those equations by using ohms equations. So now I1 can be converted into the ohms format, which means that 20 volts minus V1 across the resistance, that is 5 volt, and plus 2, and I2 across the 20 ohms resistor, so V1 minus 0, 20 ohms. Okay, so now we got the equations, and there is only one variable unknown and one equation, so we can solve it. Multiple 20 in the both sides, so we can multiple 20, we can multiple 20 in order to remove all denominator. So then this is the kind of 4, so 80 minus 4V1 plus 40 equal, this is cancelled, so V1, and now 5 V1s equal 120, so V1 is 120 over 5, which means 4 volt. So now we find out the Thevenin voltage, that is 24 volt. And then also based on the 24 volt, we can calculate the V1, V2. So 24 volts in here, open circuit voltage. Open circuit voltage, that is 24 volts on here and 0, so we know that. And now this one also here. So what happened on this side, you know? So next, so we want to calculate the short. So we want to calculate the short circuit current. So in order to do that, we can make a short circuit and then current, that is short circuit current, and this one's we say that going down directions, which means that this directions I see. Then we can make a KVLO on this side. So now current coming in, again current coming in and flow into the circuits across the R1, and then they try to split it, but there is no resistance on this circuit, so which means that I2, there is no flow of current, so I2 is 0. This is cancelled. This is kind of open circuit. So now we can redraw it. So voltage source coming in, one resistance coming in, and this is the open, so there's no current, and one current source, and they're going down and then going back. So this is the circuit. Now we want to know about SIC. That's the down directions, and this is 2 amp, and 1 I1 can pass through. So now in this equations, at this point we can make a case here. So node 2 and node 2, we can apply the KCL equations. So current coming in, I1 coming in, and 2 amp also coming in to the node, and SC short circuit current coming out. And how about I1? So just 5 ohm and 20 volts, 5 ohm and 20 volts, 20 volts. So based on the Ohm's law, I1 is 20 volt over 5, so 4 amps. So which means that 4 plus 6 IS is 6 ISC is 2 plus 4, so which means 6 amp. So now we find out 6 amp, that is short circuit current. Based on 2 information, we can calculate the RT, which means that V over I, so 24 over 6. So those are all like 4 ohms Thevenin equivalent resistance. Okay. Either you can use the alternative way in order to calculate the Thevenin resistance. We can do that way too here. So we can apply the zeroing method, so we can redraw it. So now here this voltage source, this voltage source is open circuit, and now one resistor, and this one is open circuit, and then we can zero it. Oh, this is, I'm sorry, this is the short circuit, and this is open, and the other end. Now those are connected in parallel, so we can calculate the equivalent resistance is that 1 over R1 plus 1 over R2, which means that 1 over R and 1 over 20, and which means that the 4, 5. So now cancelled 4, so R equivalent, this is 4 ohm 2, which means that this is the Thevenin equivalent voltage. Okay, so this is the one way. Either you can use that way or other way, but basically you need to find out the Thevenin voltage and the short circuit voltage and resistance.